So once we have the scatter plot for our data, we'll want to go and describe it. And there's kind of these 4 features that we can look for in describing our scatter plot. So first is going to be the form of the data, kind of the general shape. And for us, since we're doing linear regression, we really want this linear case to show up, and we'll want to be careful of this curved or no pattern case. So for linear data, it's just overall, if I made a scatter plot and I had lots of data, maybe it'll look something like this. The idea being that if you had to shape a line to this data, it would be a straight line going through. Something like that would generally follow our data. Now curved data, this can look a few different ways, but it might look linear and then at some point it turns, and maybe it just continues in that. It could even turn downward and have kind of a parabola fit to it. But the idea is if you have a line that tracks the data, eventually it'll have to curve, and we don't want this. This is something we'd want to be careful of. In terms of the calculations we're going to do, it requires that our data is roughly linear. So with that, if your data is curved, if you see that come up in a scatter plot, we really shouldn't do any further calculations with it in terms of what we're learning in this course. And then no pattern. No pattern is a case that comes up where we could kind of look at linear regression for it. It's just not very beneficial. In fact, in a later video, I'll talk about what we want to do with this data. But with the no pattern, it just kind of looks like a blob. And if we try to fit a line of data to it, what technology would do is it would graph this horizontal line as the best prediction. And with that, there's no real trend occurring. There's no form to the data. So we'd also want to be careful of this no pattern case. But especially with the curved case, absolutely don't want to use that for any of our calculations. So we want to see this linear data, and then what we could do is describe the direction of our data, and the direction fits with how the data trends, or really the slope of the line that we're looking at. So positive data is increasing data. So it's similar to what I drew up above there, where we'd start low and end up at high values. So something like this, where it's increasing, and if we had the actual equation for the line, which is something we'll be looking at, the slope is positive. Negative data would have a decreasing trend. So what would happen is we'd have our data value start up here, and then overall it would go down, something like this. So if we fit a line to this data, if we found the slope of that line, we'd have a negative slope. And then for neither is the same case as up above there with just kind of the blob of data. It's not really going positive or negative. It's that flat line coming through. All right, strength of our data is going to relate to how close is our data to the line that we're predicting with. So if I just made a line for each of these cases, let's say that's our line, we'll just use a positive case. Oof, that came out to a very different angle. The angle doesn't really matter. And then let's say weak. Now, if it's strong, that's going to be the idea that our data closely follows the line. So it wouldn't deviate very much from the line. So maybe we have a scatter plot that when we look at our scatter plot, it would look very linear. And if we drew a line through that data, it'd be very close by. Now with moderate, it'd still fit this linear trend. It would just spread out a bit more. So maybe we'd go a little bit like that. So there's just more scatter to it. But overall, it would be this moderate case of it still looks linear, and we just would have a little bit more error with the values in terms of that line as a prediction, but it's still a good fit. And then weak, well, one case for weak would be overall this, again, that blob case that doesn't have a pattern to it. Or it could even look linear. It would just be very spread out. But we could see this overall linear trend. It just wouldn't be a great fit. So those are the three strengths, and it's just a matter of looking at with the line, how close is that data following along. Something we want to be careful of is outliers and groupings. So with outliers, what that would look like is maybe we have something with a strong or moderate trend, and then we have a data value out here maybe. So what we're seeing with this is a value that's an extreme case. We can see this very clear trend here and very linear trend, but then something else happened, and we want to be careful of those outliers. In fact, when we get to a point of we're going to use technology to find this equation of the line, because what that'll do is give us all these predictions that we can make for our data. But with an outlier, what might happen is it could skew our line so it doesn't fit our data as well. It's all because of that single point. So in a later video, we'll talk a little bit about outlier analysis and how to see whether or not something is an outlier, because it could even come through as something not as extreme as what I drew, but even something like that that's clearly not following the trend. But what that could do is throw things off and give us a different equation of the line. So we want to be careful of outliers and look at our scatter plot and see if there are any clear outliers affecting our data. Groupings would look something like this, where we see this trend occurring and then something else happens. So not particularly relating to this graph, but like an example would be prices of cars and their age. The idea being, in terms of cars bought recently, there would be this decreasing trend of as a car gets older, it's worth less. But then you get to this point of antique cars. Antique cars, as long as they're well maintained, can sell them for quite a bit of money, and they end up being worth more. So you might see these different trends occurring in the data, and it could be because of a variable. It's like when we looked at bimodal and multimodal data in terms of a single variable. It's showing these different trends because there's this variable actually connecting them together. And instead of looking at all the data together at once, what we'd want to do is separate it up and look at the data separately. What is this linear trend telling us, and what is this linear trend telling us? All right, so once we get our scatter plot, and then in our next video, we're going to talk about a linear correlation coefficient, an actual value. Once we have that, we can start describing the association of our data. And typically what we'll do is it'll always, or at least it should be linear, but then we'll go into this description of direction. Is it positive, negative, or neither? And strength, strong, moderate, or weak. But then these other descriptions, we just want to be careful of whether it's curved or has no pattern. And we also want to be careful of if there are groupings in the data or outliers.